Hello, this is Mr. B, and I'm going to go over page 64 with you all, and you can follow along on page 64, filling in the definition and examples and all these little boxes for integers, rational numbers, and opposites. So let's get started. Let's talk about integers here. If I draw a number line, and I want to show you all of the integers, I'm going to start with 0 right here, and then I'm going to count. These are called our counting numbers. When we just start counting, 1, 2, 3, 4, those are counting numbers. But if we include 0, all of these are called whole numbers. Think about all the times you say whole numbers when we're writing decimal numbers and we say, oh, 2.5. The 2 is the whole number, right? It's not the fractional part. That's our fractional part right over here. So the whole numbers start with 0 and then count 1, 2, 3, 4, so on, dot, dot, dot. All of the opposites are on the other side of 0. So the opposite of 1 is -1. The opposite of 2 is -2, and so on and so forth. So you can kind of see the direction that these negative numbers go in. They're going in the opposite direction of the positive numbers, and they're counting as you go to the left. -1, -2, -3. All of these numbers that you see here, so it's all of these whole numbers included, these are all called integers. Notice that none of the fractional pieces in between them are integers. None of the fractions, none of the decimals in between. Just the numbers that you see written down here are integers. So let's go to page 64 and write out our definition of integers. That's a pretty good definition right there. It's just the whole numbers and their opposites. So key characteristics, let's write a few things down here. So no fractional parts to integers. But also they can be positive or negative. Positive and negative numbers are all integers. So let's take a look at some examples of integers. What do you think about, I'm going to write them up here in the corner. What do you think about -4? Is that an integer? Yes, of course, that was an easy one. How about 58? Is that an integer? Yes, put that under examples. How about -37.0? Is that an integer? Yes, yes it is, because 0 doesn't, that's not a fractional part. That's just, so that's the same as just -37. How about this one? 6/2. Yes, that's an integer, because 6, that's really a division problem. 6 divided by 2 is 3, so that equals 3. If I were to draw a number line, that number right here, 6/2, would be right on top of the 3. Let's do some more. How about -4 2/3? Non-example. That has a fractional part to it. How about 3/4? Okay, that's easy. Yeah, not an integer. How about 2 5/100? Non-example. That's right. That's easy right there. Okay. So you can see anything with a fractional part to it is not an integer. We talked a little bit about opposites. I mean, we kind of mentioned opposites in our discussion here. So let's just kind of jump down to opposites, and we'll put some things down here. Let's put a definition for opposites in place. All right, two numbers that are equal distance from 0 but are on either side of 0. One's on the left, one's on the right, one's on the positive side, one's on the negative side. So key characteristics, we can say one is negative, one is positive. And of course, in the definition, also a key characteristic is they're equal distance from 0. So examples are easy to come by. They can be decimal numbers, so 2.8 and, I'm going to put and, -2.8. 2 8/10, -2 8/10, 3/4, -3/4. About 52 7/10, -52 7/10. All right, so non-examples are pretty simple, -7 and 10. How about that? Yeah, they're not opposites right there. Let's jump to our last number group here, the rational numbers. Those are interesting. So if we were to look at our number line right here, we see all the integers in here. And if we were to include all of these fractional pieces, then we're talking about rational numbers. So every single thing, even all of our fractional pieces, whether it's thirds or fourths or fifths or whatever, those are all rational numbers. Everything on this number line, anything you can plot on this number line is a rational number. 0, can you plot a 0 on a number line? Yeah, it's right there. So that's a rational number. 2 is a rational number. All of our integers are rational numbers. And whether they're positive or negative, all rational numbers. All of our fractions, so negative 1/4, that's a rational number. Negative 1 1/3, that's a rational number. So there are some things that are not rational, but let's write our definition down first of all here. Definition for rational numbers are. That's it right there. Any number that can be written as a fraction. That's the official definition of a rational number. So I'm going to write it like this. A over B. That's what a fraction looks like. I'm using variables here. A variable is a letter that stands in place of a number. So if you have a number over a number, then that is a fraction. That's a rational number. The only thing you need to remember is the B, the denominator, cannot be 0. You can never have a 0 as the denominator. It just doesn't work. Even if you put it in a calculator, put in like 5 over 0. 5, put in 5 over 0. 5 divided by 0. That's a division symbol. So if you were to do 5 divided by 0, your calculator would say, no, can't do it. That's not a number. Key characteristics of a rational number can be fractions, decimals. Let's talk about decimals for a second. Some decimals are rational numbers, but some decimals are not rational numbers because they can't ever be written as a fraction. So let's just examine which ones they are and which ones are not. Let's do some examples and we'll figure this out. So let's look at this. How about 0.3? Can you write that as a fraction? Yes, you can. So 0.3 is 3/10, 3 over 10. So 0.3 is a rational number. So that's 3/10. Okay, how about 0.58? Can you write that as a fraction? Yeah, sure. You can just write 58 over the place value. What place value is it in? Hundredths. 58 hundredths. There's a fraction. So that's kind of getting easier here. What if I had 4.125? Sure, that's a rational number. You would have 4, whole number, and then the 125, 125 over the place value. What place value does it land in? 1,000. 1,000. Which, by the way, if you simplify that, is 4 1/8. So definitely that is an example here. So what we're going to find is that all of these decimal numbers that terminate, so decimal numbers that terminate are rational. So we're going to say under decimals here in our key characteristics, terminate. Decimals that terminate are all rational numbers. How about the number 0.3 repeat? 3/10 that repeats, 0.33333. Yes, that is a rational number because that is the fraction 1/3. Same thing with 0.6 that repeats. That's 2/3. So those are all rational numbers. So a repeating decimal, any decimal that repeats, it has that little repeat sign, those are all rational numbers. So any decimal that repeats, let me just repeat this. Any decimals that repeat are rational numbers. Decimals that terminate, decimals that repeat. I'm having trouble here. There we go. Decimals that terminate, decimals that repeat are all rational numbers. There are some rational numbers, or rather, there are some decimal numbers that never terminate and never repeat. I wonder if you've ever seen a decimal that never terminates, never comes to an end, never repeats itself. And I think you do have experience with one number in elementary school and 6th grade, one number that never terminates, never repeats. That number is called pi, right there. Yeah, 3.1415926. It goes on and on and on forever and ever. Never repeats, never terminates. So that is not a rational number. There are other numbers also where you'll see a symbol that looks like this. This is a square root symbol. So if you see the square root of 2 or the square root of, put some other numbers in there, 5 or something, those are not rational numbers. They will turn out to be decimal numbers that never repeat. They never terminate, so they're not rational. So I hope you got a good idea of these types of numbers. You will need to know what integers are, what rational numbers are, and what opposites are in this unit. Have a great day. We'll see you later.